Hi class, we're going to keep looking at the things from the last lesson with the different vocab words like corresponding angles, alternate interior angles, but now we're going to tell what we know about them when we know that the lines are parallel. So there's actually very specific things that are true about these angles if and when you have parallel lines, and I'll show you those to you. So if we have parallel lines, and I'll just sketch those out, and they will be marked that they're parallel with these little arrows going in the same direction. If I have some corresponding angles, like angle 1 and angle 2, when those lines are parallel, these angles here are actually congruent. So that's called the corresponding angles postulate. Here's how I'd like you to write that. I'm going to have you write that if the lines are parallel. And you can abbreviate that with just the symbol for parallel. So if you have parallel lines, then corresponding angles are congruent. For this next one, if you have alternate interior angles and you have parallel lines, so if I'm looking at these, in this case, angle 1 and angle 2 would be alternate interior angles. So when you know that these lines are parallel, those angles are also congruent. So you can abbreviate the alternate interior angles theorem kind of the same way you did the last one. If you have parallel lines, if lines are parallel, then, and I'll abbreviate alternate interior angles are congruent. And if you need to write that all out, that's fine. You'll see me start to abbreviate things more and more. For the next one, alternate exterior angles, I'm going to draw a couple lines that seem to be parallel. And if I have these alternate exterior angles congruent, well, I think I already said it. Those would be congruent also. So these alternate exterior angles are congruent. That's what the alternate exterior angles theorem says, or I think it's easier to say if the lines are parallel, then alternate exterior angles are congruent. And the reason why I think it's easier instead of remembering that this is the alternate exterior angles theorem is because in a few days we're going to do the converse of this. So it's going to say when these are congruent, then the lines are parallel. And that's the converse of the alternate exterior angles theorem. And sometimes students have a hard time remembering which one's the original, which one's the converse. So if you just start with what you know and then say the conclusion, you'll never have to remember which one's which. Okay, and then for the last one, the consecutive interior angles theorem, this is where the directions or where the theorem changes a little bit. So don't just mindlessly be copying this down and get this one wrong. Because when I have consecutive interior angles, like those two there, hopefully you can tell that if these lines are parallel, those two are not going to be the same angle measure because I have one that's obtuse and one that's acute. However, what they are is they are supplementary. So if the lines are parallel, then the consecutive interior angles are supplementary. Well, I just found my straight line tool, so maybe some of these lines will start looking a little better. For this last thing, the perpendicular transversal theorem, this one here says that if you have these lines and you have parallel lines and you have one line that's perpendicular to one of those parallel lines, then it is perpendicular to both of those parallel lines. And you're not going to have to know this theorem as much as the other ones, so I'm not going to write this out word for word. Maybe if you just kind of draw this picture. you almost could just look at these as being corresponding angles. And because this one's a right angle, this one also would have to be a right angle when you have those parallel lines. For this theorem, as long as you know that if this one's 90, that one's 90, that'll be good enough for what we're going to do. Okay, so let's do a few examples of how these will look. And in all of these examples, we're going to have parallel lines cut by a transversal. Let's start with something fairly basic, and we'll just start with simple numbers in these. Let's say that this angle here is 120 degrees. And I'm going to go through and, just for the sake of being able to talk about these, number these other angles. And I will also show that these lines are parallel with those little arrows there. So looking at these, some of the directions are going to say that you need to tell how many degrees each of these other angles are and then give a reason for it. So I'll just kind of list things off to the side. When I look at this, I always kind of start with the intersection that is on the same line. And I go through and I just write how many degrees each of these are. So angle 2 is 120 degrees because those are vertical angles. All right, the measure of angle 2. And then 3 and 1, both of those are going to be 60 degrees. And the reason for that would be that they are linear pairs with the 120 degree angle that we started out with. And then really what you could almost do is just take this and transpose it over there with their corresponding angles for this one here. So this would be 60, this would be 120, we have 120, and we have 60 degrees. But what I'm going to do is I'm going to relate them back to this angle and kind of give the reason why for each individual one. So for this one here, the measure of angle 7 is 120, and it's corresponding with that original one. For angle 5, this one here is 120, and that is an alternate exterior angle with the original one. There's no special name for like the relationship between the 120 and the angle 4, or the 120 and the angle 6 that our book gives. Some books will actually say that the 120 and the angle 6 are called consecutive exterior angles. That is not in our book, so I'm not going to expect you to know that. If you would like to give that for a reason, though, I will accept that as an acceptable answer. But what you could always do is you could relate angle 6 with some other angle. So you could say like the measure of angle 6 is 60 degrees. And if you wanted to just write because it's supplementary with 120, you could. Or you could say because it's a linear pair, maybe with angle 3. And then it's the same because it's their corresponding angles. Or you could say that the 120 and angle 7 are corresponding angles, and then these two are a linear pair. There's lots of different ways that you could describe that. Kind of the same thing for the angle 4. If you wanted to say like these are vertical angles and then these two are consecutive interior angles. You know, you could link things together in multiple different ways. Really, I think the easiest thing, at least for me, is to come up with all of this. They're either going to be congruent or supplementary, and then take that and move it to this intersection over here. They won't all look like this. Sometimes what we'll have is we will have just a bunch of variables, and they won't give you all of the different possibilities. So maybe we can do one or two like that. So let's say we know that these lines are parallel and they're cut by this transversal. And I will tell you that this angle here is 3x plus 20. And let's just say this one here is 4x minus 10. Looking at these angles, the directions will say maybe like solve for x and then find the different angles and explain your reasoning. So if that's what the directions say, I would look at these two angles and I would say, okay, these two angles here, the ones that are marked, are going to be congruent. So angles are congruent. And the reason is because these are alternate interior angles. So because they're congruent, that means that they have equal measures. So I can set 4x minus 10 equal to 3x plus 20. And I'm going to go through and solve that for x. I'll just do these steps at the same time. So x equals 30. So that would be my answer if they just want me to solve for x. If they want me to plug it back in and come up with these different angle measures, I could do that too. So 4 times 30 is 120 minus 10. This is 110 degrees. And then 3 times 30 is 90 plus 20 is also 110 degrees. And then maybe I even have to do something else. Let's say I also then have to solve, and you know that this is 2y degrees. Let's say I have to solve for that. Well, what I could do is I could say, okay, these two here that form a linear pair are going to add up to be 180 degrees. So I can set 2y plus 110 equal to 180. And I can solve that. So 2y equals 70, or y would equal 35. So you're just going to have to pay attention to what the directions say, and also look at what type of angles you have to begin with. So are the angles congruent? Are the angles supplementary? It's going to be one of those two. So if you just kind of ask yourself, are angles congruent? When they're congruent, set them equal to each other. I'll just say set equal, or are they supplementary? And then remember, then you add the two together and set it equal to 180 degrees. I hope this helps, and we will be doing lots of practice in class.